Okay, so we looked at printing last time. We're going to have to use that today because any of the work that we get our computer to do, we need to use the print function to get the computer printed out for us. So today we're just going to look at two quick little things: assigning values to variables and the basic math operators that you're going to find in Python. So let's get started. Assigning variables in Python is very easy. You simply give the variable a name. It can be anything as long as it doesn't have any of the restricted characters. We'll go over the restricted characters at another time. But it's easiest if you just use lowercase letters and underscores to separate words because you can't have any spaces. For right now, I'm going to stick to everybody's normal math conventions. We'll just use letters. So x equals, and give it a number, 12. Y equals 3.4. So here's two different types of variables you're going to find as part for numbers. Data type, the first one, 12, is an integer. It has no decimals. And the decimal number on the bottom will be saved as a double type. As we do operations on them, whether or not you're adding, subtracting, multiplying, dividing, sometimes an integer values will turn into doubles if you're doing something like dividing, but otherwise they'll stay as integers. So the basic math operators: addition, subtraction, multiplication, division, modulus, which we'll get to. We'll talk about it a little bit more, but it basically gives you the remainder of a division question. If you want to do an exponent, or floor division. The floor division gives you the last whole number that's fully divided. So if you go 9 divided by 2, you're going to get 4. Because it's going to go to the last whole value. And we'll just look at those really quickly here. X plus y. And I'm just going to put after that, put a comma here. X plus y, and then I'm going to just put after that addition. And I think you can see the pattern here, so I'm going to stop talking and just get this all in. So I have them all printed out here. I think this is ready to run. We'll see if we get any errors with the values. I put it in a second. But I just sort of laid them all out here so we can see them. And you'll notice I used a whole bunch of print statements last time. I said I don't like to do this. I'm going to do a whole long print statement that I want multiple lines. I'll try to nest them all within one print statement. The difference here is that they are all separate actions. So if making the code out this way kind of helps to read that out. So I don't mind doing that. Almost like it's a new paragraph, I put a new print statement. And that's not at all a rule. That's just something I tend to do when I write my code. So when we run these, we get all of our answers here. If we add the two, we get 15.4, subtractions 8.6, multiplication 40.8, division, we get a nice long double here. We do the exponent, then we do the modulus. We get this odd value that I want to just get into a little bit here. So if we take 3.4 divided by 12, we're going to get an exponent, and you can see it goes way down here, and there's this 3 sticking out. That has to do with the way that the variables are actually held. Sometimes the rounded values aren't exactly what we'd expect in base 10 math because of the way that the computers handle the numbers. And then at floor division, you'll see that 3.4 goes into that 12. And we divide that and we get down to 3 because it doesn't quite go 4 times. So those are the operations. What we did was we were able to assign variables given just giving them a name, and we were able to do the basic math operations. Okay, let's use this for something a little bit more complex. And let's solve a quick little physics question here, how long it's going to take us to stop on an average road conditions from 100 kilometers an hour. So when we get into here, we're going to have to assign some of our variables. So we'll get our initial velocity, and that will be about 28 meters per second. we'll have to get a coefficient of friction. We'll just call it U here, coefficient of friction. And then we'll give that the average. Its coefficient of friction on normal roads is about 0.7, so we'll keep it with that. You can get higher, and if the road conditions are worse, it'll be lower. So we're going to stick with that, and G is the acceleration of gravity, and that's 9.8. We're close enough too. A little bit different depending on where you are on the globe and how high you are. So we have our basic values there. Our formula is going to be that distance is going to equal our velocity squared, so we're going to have to use the power. So velocity 2 power of 2 divided by, and we're going to have to do a couple things on the bottom, so we're going to have to put it in brackets to keep our bed mass working. 2 times our coefficient of friction, which was U, times G. And that's our formula right there. Now we have distance is V1 to the power, V1 squared divided by 2 mu G. And that gives us the distance it's going to take us to stop. Right now it hasn't done anything as far as printing, so I'm just going to print this out. And I'll just print D, or hit run on this. And it says that it's going to take us about 57.14 meters, about. It's quite precise there for about. But that's how we're going to calculate it. We follow the bed mass rules within our calculation, and then we were able to get a printed value at the end. And then we can just go through and change the values if we wanted to a little bit. So if I said, how long is it going to take me to stop on an icy road? So that's about a 0.4 coefficient of friction. If you have some good tires, that's a 0.4 coefficient of friction. So if we put that there, all the values the same, still going at highway speed. Now it's going to take me about 100 meters to stop. Right now, our programs aren't very interactive with the user. They're just all the values are put directly into the program and then run. Next time we're going to get looking at how we can get values from our user and ask them to type in values for us and use those.